In this video we will find out about what flames and fire are and how we can get an idea of the temperature of different flames. We'll also take a look at what it takes to produce fire and to extinguish it. Fire is a chemical reaction. It requires a fuel, a substance that will react with oxygen and produce heat when it does so. It also requires oxygen for the fuel to react with, which usually means a supply of air. An oxidation reaction of this kind is referred to as combustion. Not all substances that react with oxygen are fuels. Some substances react slowly with oxygen and don't produce fire, for example iron when it rusts. Burning is another name for the combustion reaction when a fuel reacts with oxygen. We need to be careful about how we use this word. Just heating something up is not burning it, even if it melts, unless it also starts to react with the oxygen in the air. Flames are the gaseous parts of fire. Gases are produced when substances burn, and the heat energy produced by the combustion reaction causes these gases to get so hot that they glow, which is what we see as a flame. In some flames, the gases get so hot that the atoms fall apart, losing electrons to produce a state of matter called plasma. Flames can be all sorts of different colours, and these colours can tell us about how hot the flame is and what substances are present in the flame.
Well, can we burn just any old gas then? Actually, no, we can't. Here we have some hydrogen. Hydrogen burns very easily, so this is hydrogen and oxygen burning. It's a very, very hot flame, and we'll come back to this later. But there's very little light coming out from this. So there's a lot of energy being given out, but it's mainly in the form of heat energy, not very much light. So how come our gases that are burning in the centre of the stage there give out quite so much light? Well, one of the important things we need in the gas is the carbon. And what we're actually seeing here are little particles of carbon, soot, that have been heated up, and so they're glowing, and it's that glowing that we see here. So the fuel needs to contain some carbon in order for us to see this. And I can show this, actually, with a piece of white card here. So if I just hold this over my Roman lamp, I should be able to trace out. So that's the soot given out from this lamp, the black soot there, and this is carbon that's formed due to the incomplete combustion of the fuel with the oxygen. But it's these particles of carbon that give out all the light that we see.
When solids get hot, they begin to glow. Firstly a red colour, then orange and yellow, and eventually white as they get hotter and hotter. Small solid particles in flames get hot and glow, giving us an idea how hot the flame is. We can see this in the flame from a Bunsen burner. The fuel burning in a Bunsen is the gas methane, but the way it burns depends on how much oxygen there is for the methane to react with. When the air hole is shut, one of the reactions taking place is methane burning to make tiny particles of carbon, which we know as soot, and water vapour. The tiny soot particles are heated in the flame until they glow. Their yellowy-orange colour shows us that the temperature of the safety flame is around 900 degrees C. As the air hole is opened, we have more oxygen present, so the methane is able to react differently, making water vapour and carbon dioxide. There are now no solid particles in the flame, so the yellow glow disappears, and instead the hot gases in the flame produce a faint blue glow. The temperature in the flame is now nearer 1600 degrees C. Just having a supply of oxygen and a fuel is not sufficient to produce fire. We also need a source of ignition, heat enough to start the combustion reaction. The fire triangle shows the three things, all of which are needed before a fire can happen. If we want to stop the burning reaction and extinguish the fire, all we have to do is remove one of these three things. The fire will go out if we can remove the fuel, or stop air getting to the fire, or if we cool the fire down enough for the burning reaction not to be able to continue. One type of fire extinguisher contains foam. This is sprayed over the fire, blanketing it. This prevents oxygen getting to the fuel, so the burning reaction stops and the fire goes out. Another type of fire extinguisher uses water which is sprayed onto the fire. The water causes cooling, breaking the heat side of the fire triangle and stopping the combustion reaction. It's dangerous to use water to try to put out burning oil or fat, though. The fire is so hot that the water boils into steam as soon as it reaches the fire and carries a cloud of burning oil droplets up into the air.
Okay, I think we've got ignition here. We can have the gas off. Gas off. Okay, ready?
Yeah.
Forest fires can be prevented from spreading by leaving strips of bare ground between areas of forest. These are called fire breaks. Because there are no trees in the fire break, there is no fuel to burn and the fire triangle is broken when the fire gets to the fire break.